Hello students, hope you're doing great. Welcome to the fourth practice set of the SAT series. Let's get started here. Uh, Absolute value of x minus 1 is equal to 1 and we have to solve for x, right? So the first thing obviously which comes to our mind is to bring this 1 to this side so that we have absolute value of x minus 1 is equal to 1 plus 1, which is 2, right? Now as we discussed earlier, right, in the absolute value sessions, what this means is that the entity inside the absolute value, this x minus 1, this entity, it can be equal to 2 and it can be equal to negative 2 also, because when this entity is 2, the absolute value of 2 would be 2, and when this entity is equal to negative 2, even in that case the absolute value of that entity will be equal to 2, right? So we can kind of break this equation into two scenarios. The first scenario would be x minus 1 is equal to 2. This entity inside is equal to 2, and the other would be the entity inside is equal to minus 2, and then we solve for each one of them. So this gives us the value of x as 3 because we move 1 to this side, and this one gives us the value of x as minus 1, and we move minus 1 to this side, it's minus 2 plus 1, which is minus 1. So these are the two values of x is equal to 3 and x equal to minus 1, for which this equation will hold good. So we have two lines L1 and L2 such that both of them are perpendicular. L1 is perpendicular to L2. Essentially they make an angle of 90 degrees with each other, and we have to find the value of A, right? So two lines are given, some points on each of these lines are given, those two lines are perpendicular, and we have to find the value of A, right? So pretty straightforward question, right? We can find the slope of this line, we can find the slope of this line, and we know that the relation between the two slopes will be that the product of the two slopes has to be equal to minus 1 for the two lines to be perpendicular, right? So let's find the slope of line L1, let's call it by M1. So M1, which is the slope of this line, would be y2 minus y1 divided by x2 minus x1. So 1 minus minus 3 divided by 2 minus minus 4, right? Or 1 plus 3 divided by 2 plus 4, or 4 over 6, or 2 over 3, right? So 2 over 3 is the slope of this line L1. Let's find the slope of line L2, and let's say we call it by M2. So M2 would be again y2 minus y1 divided by x2 minus x1. So 4 minus of minus 2 divided by minus 1 minus A, right, which is nothing but 4 plus 2 divided by minus 1 minus A is equal to 6 over minus 1 minus A, correct? So this is the slope of this line L2. The slope of line L1 is already this. So the product of these two has to be equal to minus 1, correct? So 2 over 3 times this slope, 6 over minus 1 minus A, is equal to negative 1, right? The slopes of each of these lines, the product of those has to be equal to minus 1 because these are perpendicular to each other. Now we can solve this and we will get 4 over minus 1 minus A is equal to minus 1. We can do cross multiplication and we get 4 is equal to 1 plus A, or A is equal to 3, right? So again, just to reiterate, right, these two lines are perpendicular. We found the slopes of each of them. The product of those two has to be equal to minus 1, and we solve that to get the value of A. Okay, question number 3. So we have a situation wherein there is a person, let's say Jack, he walks from home to park at a speed of 8 miles per hour, right? And then he jogs back from park to home at a speed of 6 miles per hour, okay? And in this total exercise, going from home and coming back to home, it takes 42 minutes for him, right? And we have to find the distance between the home and the park. So that's the situation here. Now, to get started, right, we should obviously know the relation between the distance, time, and speed, and we know that distance is equal to speed times time, correct? Distance is equal to speed times time, or in other words, we can also say that time is equal to distance over speed, correct? Now in this case, obviously we have to find the distance. Let's say that the distance from home to park is d, right? If the distance from home to park is d, then the time taken by Jack in jogging from home to park would be d over the speed, which is d over 8, right? So d over 8 is the time which Jack takes in jogging from home to park. Similarly, the time taken by Jack in jogging back from park to home would be d over 6, right? So time is distance over speed. We know the speed while going, hence it's d over 8. The distance obviously remains the same. So the time taken by Jack in coming back is d over 6. And we know that this total time is equal to 42 minutes, is equal to 42 divided by 60, because we want to keep everything in hours, right? So the left side, the time is in hours, so we have to keep the time in the right side also in hours. 42 minutes is equal to 42 divided by 60 hours. Hence, we get this equation which we can solve for d, right? So let's do that. The common denominator would be 24. 3d plus 4d would be 7d is equal to 42 over 60, right? We can cross multiply. So we get 7d times 60 is equal to 42 times 24. We divide by 7 times 60 here. We divide by 7 times 60 here, right? And we get the value of d as 24 over 10, or 2.4 miles. So that is the distance from home to park. Just to quickly reiterate, right, we know that the distance is speed times time, or time is distance over speed. We know the time taken by Jack in going from home to park. We know the time taken by Jack in coming back from park to home. We added both the times because we know the total time is given as 42 minutes, or 42 over 60 hours. And then we solve this equation to get the value of t. Okay, question number 4. So we have a function y is equal to fx as shown on the board, right? And there's another function gx is equal to k, okay? And it is given that fx and gx can have only one solution, and we have to find any one value of k, right? So before we get started here, we need to understand a couple of things here, right? First of all, we know that how the function fx looks like, right? The shape is going to be like this. They've also given us 2 points, the local maxima point here -1, 2, and they've also given the coordinates of this point, which is the minima, local minima 0.25, -3, correct? So we pretty much know the shape of fx, right? We need to understand what will be the shape of gx equal to k. Now gx is equal to k is nothing but a horizontal line parallel to the x-axis. It's like saying, okay, what is y equal to 5, right? So how do we draw y equal to 5? Y equal to 5 is nothing but this line, right? This line is y equal to 5. Similarly, gx is equal to k is nothing but a horizontal line, and depending upon what value of k it will be, the horizontal line could be anywhere. Suppose k is 1, so it will pass through 1, so horizontal line will be this. If k is 5, horizontal line would be this. If k is -1, horizontal line would be like this, correct? So the first thing which we need to understand is that how this function will look like, right? So it's a horizontal line parallel to x-axis, and depending upon the value of k, it will have a different y-intercept, right? That's point number 1. The second thing is that for the two functions, or for any two functions to have one solution, what does it mean? It means that they should have only one point of intersection, correct? One solution means only one point of intersection. So essentially the question boils down to the fact that which could be that horizontal line, such that that horizontal line and this function will have only one point of intersection. Let's take an example. Let's say that we put the value of k as, suppose, -2, right? So it will become gx is equal to -2, right? And how will this line look like? This line will look like this, right? How many points of intersection we have between this line and this function? We have 3 points of intersection. We have this point of intersection, we have this point of intersection, and we have this point of intersection, correct? So clearly gx is equal to minus 2 does not have one solution, so it does not satisfy our requirement, correct? So essentially what does it mean? It means that the line will have to be anywhere below minus 3, because if it is below minus 3 it will intersect only at one point, this point, correct? Or it has to be above 2, because if that line is above 2 then it will also intersect only at one point. Between 2 and minus 3 it will have multiple points of intersection, so it will have multiple solutions, right? So our value of k could be any value greater than 2 or any value less than minus 3. So either above 2 or less than minus 3. We can pick any value, or this is the range. Just to quickly reiterate, right, this is a very good question. It does not require any kind of a calculations. It just needs understanding. First of all, we need to understand how this function will look like, right? It's a horizontal line. And secondly, what is the meaning of the ask here? One solution means one point of intersection, right? And this is our range of k. Okay, well, last question here. So two numbers are in the ratio of 7:5. When 2 is subtracted from each of the numbers, the ratio changes to 3:2, right? And we have to find the numbers, right? So let's understand, right? When any two numbers are in the ratio of 7:5, what does it mean? What are those actual numbers? We don't know the actual numbers, we just know that they are in the ratio of 7:5. It means that there would be some common factor which is getting cancelled out maybe and giving the ratio of 7:5. Right? So it means that we can say that the first number could be 7x and the second number could be 5x, right? Because if the first number is 7x and the second number is 5x, then what will be their ratio? Their ratio would be 7x over 5x. X and x gets cancelled, we get 7:5, correct? So we can say that this is our first number and this is our second number, the actual numbers. Now when 2 is subtracted from each number, so let's say 2 is subtracted from this number, so it becomes 7x minus 2 and this becomes 5x minus 2. And in that case the ratio changes to 3:2. So basically 7x minus 2 divided by 5x minus 2 is equal to 3/2. This is our equation, correct? And then we can solve it as we saw earlier, right, in the fundamental series. It's a single fraction on the left, a single fraction on the right, so we can do cross multiplication and we get 14x minus 4 is equal to 15x minus 6. We bring x to this side and 6 to this side, so we get x is equal to 2, right? If x is equal to 2, then the first number would be 7 times 2, which is 14, and the second number would be 5 times 2, which is 10. So these are our two numbers, 14 and 10, right? Just to quickly reiterate, right, we know that the two numbers are in this ratio, so we said that, okay, let the actual numbers be 7x and 5x, and as per the second information, 7x minus 2 divided by 5x minus 2 is equal to 3/2, and we solved that to get the value of x. Once we know the value of x, we can plug it back here to get the first number, which is 14, and the second number, which is 10. If folks, hopefully you like the video, keep practicing. In case of any questions, please feel free to reach out to us at info.mathletes@gmail.com. See you in the next session. Thank you.